Hey, so this will be a brief intro to SNMP. It may be a multi-part series. We'll see how it goes. So what is SNMP and why do we care about it? Well, it's a standardized network protocol that allows us to monitor a wide variety of devices. And it doesn't matter what type of device it is or who makes it. It could be a Juniper, it could be a Cisco, it could be Eureka, it could be Barracuda Networks. It could be anybody. As long as they support the SNMP standard, you can monitor all sorts of interesting stuff using SNMP. So I should start by pointing out that SNMP is not considered terribly secure. It's not something you would want to do in the clear over the internet. You'd want to run it over a VPN tunnel or something like that. In fact, ideally, some people have a separate VLAN for their management of their network devices, and that would be a good alternative as well. You could just run all of your SNMP traffic over that same management VLAN. That's the ideal. If you can't do that, you want to at least use SNMP version 2C or SNMP version 3. SNMP version 2 doesn't really have any authentication as such. It has what they call a community string. And as long as you know the community string, you can monitor the traffic. I don't recall if there's any crypto in SNMP2C. I don't think there is. SNMP v3, I believe, can support crypto, and it has the concept of a username and a community string. You can kind of think of the community string as a password. And with SNMP v3, you can also typically set up permissions, ACLs, so you can say this username is allowed to see these parts of the SNMP tree, but not others. In most devices, let's stick with SNMP v2c for now, for simplicity's sake. And in most devices, there are two community strings, and one of them has read-only privileges, and one of them has read-write privileges. You never want to use the default community strings. So the default is public and private for the community strings, and you always want to change those. The kind of information that's available via SNMP, you wouldn't really want to make available to just anybody and everybody on your network. It's typically not terribly sensitive, but it's the kind of thing that you don't really want to expose. So not only do you want to change to a different set of community strings, I would actually recommend only doing read-only unless you really know what you're doing. I don't really want to grant read-write privileges to my devices to a networking protocol that is not 100% bulletproof. So, and not to mention, I don't really trust most SNMP-based tools to be making changes to my network devices. I kind of want to go through the whatever management tools the manufacturer provides for actually making configuration changes. There are some tools that you might trust to use SNMP to manage devices. That would be if that was their sole purpose, and you really knew that they worked and they were aware of all of the different types of devices that you're managing. But for the most part, stick with SNMP read-only mode, and just for monitoring purposes, and you'll be just dandy. And it allows you to do a lot of really cool things. So let's look at a few of them. So this is a Cacti server I have at work, and you can see I'm monitoring a wide variety of things on this particular system. So you can monitor, these are all different systems, and I'm monitoring the CPU usage. But instead of just a percentage of how busy it is, because this is a Linux system, I can also actually monitor what types of CPU usage there are. So the red is the operating system, yellow is waiting on I/O, blue is user space. That's usually your applications, whatever they are. Sometimes kernel will show up in here, and nice if you run things, different processes with different privileges. And then idle is the idle trace. And in this case, the graph goes from 0 to 800 because this particular system has 8 CPU cores. But you can also monitor a wide variety of things on the system. So on a given server, you can monitor things like the number of processes that are running, the number of users that are logged in. You monitor Ethernet traffic, and not just the number of bits per second sent and received, but you can actually monitor the error rate on individual Ethernet ports. So this is great. You can get the same sort of stats whether it's a server that supports SNMP, or if it's a router or a firewall or a switch port or whatever. If it supports SNMP MIB2, you can get access to all of this sort of data, and you can put together checks that look for problems like too high of an error rate, for instance, and it could then notify you that, hey, serial number whatever on firewall whatever or router whatever is getting a high error rate. Maybe you should call the telco. You can also make plugins, or in my case, I've written a bunch of plugins that are SNMP based that fetch things from vendor-specific data. So, for instance, this is an old Dell system, and I made a plugin that connects to the Dell, and it checks for the status of a wide variety of things. Basically, I just look at whatever devices are there and what their statuses are. So this particular server is reporting the power supply, the temperature probes, the memory status, the voltages, the cooling devices, all the fans, and everything is okay. But sadly, most people don't monitor stuff like that, and they get bitten when one of their redundant power supplies fails. Everything continues to work until the second redundant power supply fails, and then the server goes down. And then managers get cranky and ask, well, if we have these redundant power supplies, why does nobody do anything when the first one fails? So it's a good idea to monitor what you can and react to it before it becomes an actual problem. And SNMP is a great way of getting access to a lot of that data. Okay, so one aspect of SNMP that we haven't really spoken about yet is traps. And that's another really nice part of SNMP that you may or may not want to make use of. If you have some software that can act as a trap receiver, you can have your devices configured to send that device a trap anytime something interesting happens. In fact, you can usually configure different levels of traps that you want to be notified about. And it's a proactive notification system. So this is a tool that once upon a decade ago I used at a previous job, and it started off life as a network diagramming tool. It's called Scotty. And people gradually added to it. So it has an SNMP browser, it has some troubleshooting tools, it has an SNMP monitoring tool, it has a wide variety of things glued into it. So in addition to diagramming your network, you could proactively monitor it. You could actually go and probe it and see what was happening. You could have active graphs that would update every 60 seconds or every 5 minutes or whatever, that would show you CPU stats and traffic stats and error rates and things like that. It's kind of cool. It's unfortunately a little hard to get and a little hard to compile and make run these days. The source is not really actively maintained anymore, last I checked. In fact, if anybody's looking for a really good project that would really make a lot of Linux and Unix admins happy, a replacement for Scotty would be great. But anyway, one of its features is it has a trap sync. So you can fire up a trap sync and tell it to listen for traps, and then you can tuck this away somewhere on a separate screen, a separate virtual screen, or just minimize it. And then as soon as your firewall sends a trap, or your router, so you've got a router with a T1 connected to it, and the T1 goes down, it sends a trap that opens up a separate window, just pops open a window saying, this router just said interface such and such just went down. So that can be really useful. Some monitoring tools now, what they'll do is they'll set up a trap server that just listens for traps and then sends a passive nagios notification to nagios, and then nagios sends the notification on to whoever might care about the networking gear. But whatever. So let me just check my notes here. So I can instinctively feel somebody out there asking a question, why SNMP? right? I mean, all of these devices, they have their own web interface. You can go log into the Checkpoint firewall admin interface, and you can see traffic stats on it, and you can see hit rates and things like that. You can see the status of the devices. So who cares? Why do we care about SNMP? The difference is that you're not tied to a specific vendor's tool, right? I can have a Juniper firewall, some Checkpoint firewalls, some Cisco ASAs, some Cisco switches, some 3Com switches, and some Brocade fiber channel switches. And I can monitor them all via Cacti. I can monitor them all via Nagios using SNMP. So that's the difference. You're not tying yourself to a whole bunch of different interfaces to monitor a whole bunch of different vendors' gear, right? You can go to one place and monitor all of it. You can go to one dashboard or one pane and see the status of everything. That really is the big win for SNMP. So let's take a look at it and see what the data looks like. One of the cooler features in Scotty is it has this thing called a MIB browser. That lets us browse through the things that we can search by, the data we can search for. And if you don't have Scotty, and probably very few of you do, there's another tool. Actually, I'm just going to fire it up from the command line. There's another tool you can use called TK-MIB, and this is just, you can get this from any Debian distro has this, and it lets you do the same sort of thing. There's a few things in Scotty that I like better, so I'll be switching back to Scotty at some point, but let's start here. So everything in SNMP is represented by what's called a MIB-OID, or OID. MIB is short for, if I remember right, Management Information Base, and OID is an object identifier. So basically, it's a numeric code that represents a specific spot in a tree of data. So this ISO is 1, and 3 is org, 6 is DOD, and 1 is internet. So that 1.1.3.6.1 represents that spot in the MIB tree. Now this is where typically everything starts anyway. In fact, most things actually are beneath this management MIB2 branch. And the reason for that is that this is a standardized branch. If you call up your hardware vendor, whoever it happens to be, Barracuda Networks or Cisco or whoever, and you say, do you support MIB2? They'll know immediately what you're talking about. This is what they're talking about. They may only support certain parts of the MIB2 branch, but they'll support something in there. So for instance, that you can gather information about a particular device. You can get the description and the uptime and who the contact is and its location if that's set up in the device. There's a bunch of standardized things you can fetch. One of the ones that we were looking at earlier was the traffic graphs. That would be underneath interfaces. You can see you can get to an interface table and then specific entries in that table. And then you can look at the description of all the interfaces on that device. You can look at the type, the MTU, the speed, how fast, is it a gigabit or 100 meg or 10 gig or what is it? You can get the operational status, is it up or not? This is also where you'll get the traffic stats and the error rates. So when you see something that says octets, that's just a SNMP speak for a byte. So if you measure bytes per second, one thing to remember is the SNMP data is in bytes per second. Typically, a lot of people want to see the traffic stats in bits per second. You'll need to multiply by 10. That'll be pretty close to the number of megabits per second. And typically, your monitoring tools like Cacti, they'll do that for you. You just tell them, I want to graph in bytes per second or bits per second, and they make that transposition for you. So you can get all sorts of information about traffic stats there. You can get information about the IP stack. So if you go browse around here beneath IP, and this is why I brought up TK-MIB, it's a great way to kind of get started just browsing through the MIB tree to see what data is available. You'll find things like the routing table will be in there somewhere. Host is another branch that's sort of interesting. Not everything supports the host MIB, but a lot of things do. We won't pull that open just yet, but I'll show you that later. So you can get information about a server, for instance. You can get things like what sort of devices are connected to it, storage devices. You can see what file systems are mounted and how full they are. What software is it running? What software is installed? There's all sorts of information that you can get a hold of. You can go down into device, and not only can you look at disk devices, you can look at processors. How many CPUs are there, and how busy is it? All sorts of information that's available via SNMP. And there's one that's not listed here. I appear to not have that MIB loaded. We'll get there in a minute. But there's one called FC Management. It's underneath experimental. That's why I'm not seeing it probably. And you may find that useful if you have any, this one doesn't have the MIB loaded, but you might find that useful if you have any fiber channel switches. One of the things I found was that underneath the experimental branch there's this fiber channel management branch, and it has a standardized MIB for monitoring fiber channel switches. So whether it's a QLogic or a Brocade, those are the two that I've definitely tested. They both support that standardized MIB tree. You can, if you have a tool that will monitor that particular stuff, monitor devices using that particular branch of the MIB tree, you can then, in a standardized way, monitor the traffic stats of your fiber channel switches. We were using that specifically because I was drawing dashboards in Nagios that would show Ethernet ports and fiber channel ports and show the traffic flowing across them. So we could see if there was any contention for a specific port on the switch, where we bottlenecking on one port, where we load balancing across all the ports correctly, that sort of thing. And so I used that because we had multiple kinds of fiber channel switches. I used that branch of the MIB tree in order to monitor it because that was standard and all of the switches supported it. So what it meant was I only had to teach Cacti how to monitor that particular SNMP MIBoid once. I didn't have to teach it how to monitor Brocades and then teach it again how to monitor QLogics using two different parts of the SNMP tree. So another part of the MIB tree that you'll find very useful is this private one. Now when you do have things that are specific to a specific type of device, you'll find it down here beneath enterprises. So for instance, this UC Davis, you'll see UC Davis and net-snmp. UC Davis, net-snmp used to be called UC Davis. It was developed originally at that university by a really nice guy, and whose name I've forgotten now. But anyway, so a lot of what you want to monitor from net-snmp is in this UC Davis branch of the MIB tree. So if you're monitoring Linux systems or any Unix system that's running net-snmp, so Solaris, DEC Unix, HPUX, any of those, I've run net-snmp on IRIX. You can get a hold of the process table, the memory, and disks, and load averages, and system stats, and CPU stats, and all kinds of stuff. Log match is another one that's really cool. You'll want to read the man pages on at some point. Actually, what we should do is have another video specifically on net-snmp and all of the cool things you can do with it, how you can glue new stuff into net-snmp. Like I made a Perl script that would fetch stats from a postfix server and hook it into net-snmp, and then I would use SNMP to monitor my postfix relays. I could get stats on how the postfix relays were behaving, how many email messages they were accepting, delivering, or rejecting. So yeah, we'll make that a whole separate class. So so you get the idea that this data is in a tree structure, and as you browse around the tree, you'll see this OID changing. That's the OID of where you're looking at, right? So if we go into the memory table and we go to total real, that's the MIBoid that we would want to feed into some other tool like say cacti, we wanted to teach cacti how to monitor the real memory on a system. We could go into it and set up a data template and say, I want you to fetch this miboid and call it memtotal real. And then you could refer to that in your graph templates when you were building graphs. So the only reason I'm bringing that up is some of the devices, if they know your MIB file, if they've loaded your MIB file, you can refer to it by name. If they don't know your MIB file, you can refer to it by this numeric miboid. That always works. Even if some software doesn't have the MIB, doesn't load the MIB, can't read the MIB for whatever reason, you can always just feed it this numeric miboid. So what we should do next is take a look at one of these files. I'm going to kill tkmib temporarily. And let's go to Barracuda spam. And so these are the 3 MIB files for the Barracuda spam firewall that I have at work. And when you're looking at MIB files, before you start loading them into Scotty or tkmib or things like that, you'll probably want to know what MIBs you want to look at and in what order. When you load them, the order is important. So for instance, if we look at this one, this contains the stuff that we want to fetch and monitor, like queue sizes and actions, and you can see it's got information about the fans and system load and things like that. But if you look at the top here, you'll notice there's this section called imports. So it's saying I'm going to import module identity object type and integer from this. Now that's just standard SNMP v2. Any tool that you're using that supports SNMP should already know this MIB. But it also imports the word Barracuda from a MIB called Barracuda ref. Well, that's the other file that we were looking at. So here you can see it defines Barracuda, and it says this is something that's being read by the SNMP software, mind you. Barracuda is enterprises plus .20632. So that's the same as going to private enterprises, and then depending on, remember that miboid, whatever miboid we were at, we would depend on a 20632. And then if we look at our original file, you'll see that the first thing that it defines is bspam. And we'll page down. And bspam is Barracuda, which is that enterprises, whatever that number was, plus a 2. So let's load those into tkmib, and I'll show you what that looks like. So if we go to private enterprises, you'll see our miboid is 136141. Let's load a new MIB file. So we know we need to load, if we load this spam one first, it's going to fail because it doesn't have all of the prerequisites, right? So let's load the reference file first. And then we didn't get any errors, that's good. So now let's load the next one. Whoops. There we go. So now, if we load up private enterprises, and we scroll down, looky there, there's our Barracuda, and you'll see that sure enough it matches what was in the MIB file. It's enterprises.20632, and if we expand it, you'll see there's bspam. And if we expand it, now you see there's all the other stuff that's in that MIB file, the things that we ideally we would want to get a hold of, so that we could make a nagios plugin to watch for the queue sizes, or to watch for the RAID status, or the fans, or the power supplies, or any of that good stuff, the queue sizes, right? This is, let me move that into the recording area. So this is all the stuff that you would not be able to get a hold of through just standard old MIB2. Now the CUDAs also support MIB2, so if I just wanted to monitor Ethernet traffic and things like that, I would just use MIB2 to do that. So I found recently when I loaded TKMIB on this newer Ubuntu, I found that it didn't load all the MIBs by default. But if you add this package, this SNMP MIBs downloader, and then wait 5 or 10 minutes, it'll go and download all of the additional MIBs. They're not immediately available. But if you look at this snmp.conf file and comment out that line, now most of the Linux SNMP tools, including TKMIB, will know about those other MIBs like MIB2 and the host MIB and stuff like that. I also found that you can put those same settings in your own home directory. So if we look at /.snmp, there's no MIBs file, and there's a TKMIBRC, that's the settings for a TKMIB, but there's no snmp.conf file there. And I found out by trial and error that TKMIBRC does look in here for MIBs directories by default, and it looks in here for an snmp.conf file by default. So we'll cover that real quick. That's a useful thing to do. It'll make it a lot easier than manually loading the MIBs like we were doing to browse the MIB tree. All right, so let's talk about how to customize our own environment so that it will, TKMIB and things like that will automatically find the MIB files that we want. That'll make it a little easier to get started browsing the MIB files for your devices to find out what data is available and what you can monitor and what you can watch for. So let's copy etc snmp, snmp.conf to /.snmp. And when you first load all the SNMP tools on a Linux system, this is the way it looks. It's uncommented, and that means don't load any MIBs. I guess there's some proprietary stuff in some of the MIB files, and so they don't want to be sued by shipping the MIB files. But if you get that extra package I showed you, that'll download all those MIBs, and then you can comment out this line, and that tells it load all the default MIBs. Now that'll get you things like MIB2 and UCD-SNMP or UC Davis and net-snmp. But if you uncomment it and you append to it the word all uppercase, just like that with no space after the colon, now when you fire up TKMIB, we get some errors, or at least some warnings about a couple of the MIB files. Apparently TKMIB, or the library that it uses, doesn't know how to parse those MIBs. But if you look here, you go to private, enterprises, looky there, we've got a whole bunch of MIB files loaded. So that's good. And we can take it a step further. We can make a directory in /.snmp called MIBs. And we'll copy our 2 Barracuda MIB files there. And now when we start TKMIB, we go to private, enterprises, and there's our Barracuda MIBs. So that's how you can add the MIB files for your devices, for your vendors, and just start browsing. You can use TKMIB to get started very simply, just to start browsing around the data to see what's there, what format it is. We haven't really chatted about this center panel. When you start browsing, you may want to start paying attention to the type of the value and what the comments are about it. So, for instance, this one happens to be an integer. There's going to be some that'll call themselves, that'll be called counters, and those will become important. But I want to use a different tool to look at some of those. So let's go ahead and shut off TKMIB. Let's switch over to Scotty. And its setup is a little different. I'll show you just for grins, but we should really have Scotty be its own separate video. So there's this file called site.tcl, and inside here you can put in these lappend statements that tell it the name of MIB files to load. You can see I've got a whole slew of stuff that I've put in, and some of it that I've commented out. So the more MIBs you add, the longer it takes to do things in Scotty, like load the SNMP browser. So I typically will put in what I'm looking at and then comment it out when I'm done and no longer care about it, or I'll leave it in if it's something that I go browsing through a lot. But we should see, yep, there's Dell. And this my server is a really old Dell system that I have for doing some testing with, poking around with. So here's our baseboard group. I'm going to make this a little bit bigger. And our thermal group. And let's go to cooling device table entry. And you notice that this one's not really telling us the MIBoid as we go along, but it will eventually. I'll show you in a sec here. So let's go to cooling device reading. There we go. So it just made an SNMP query of cooling device reading, which happens to be, should show us, here it is, the identifier. That's the full numeric MIBoid to get there. And inside here you'll notice that it has cooling device reading. That's this big long MIBoid plus a .1 and a .2, and then it finally has the fan speeds. The reason that's important is that when you use the command line tools and you try to fetch a specific MIBoid, or if you're, say you're making a data template and you want to specify for this exact make and model of Dell these exact 4 fans, the MIBoids that you would feed into Cacti or whatever your monitoring tool is would be this big long MIBoid, plus you would append on a .1 and then another .1 for the first fan, a .2 for the second fan, a .3 for the third fan, etc. And that would get you the RPMs. You'd also want to look at the comments. You'll notice this one, it says this attribute is the fan speed and RPM or the off-on value of the cooling device. So apparently some of the older model stuff, they don't give you the RPMs, they just say if the fan is on or off. So if you're writing a Perl module or something for nagios, that would be something you might have to take into account. My general rule is I use something like Scotty or TKMIB, and I poke around in my MIB tree first and see what it looks like and what the data that's being returned is. Or I'll use the SNMP command line tools to fetch that same data. And then that gives me a better idea of what I need to write my Perl script to be able to handle. So that brings me to another quick topic. So I mentioned we did I clicked on one of the entries. You can also click on, instead of doing a get, so if we go to one of these things and we click on it, like the status, it implies to do a get of everything beneath that MIBoid. Here you can see our fan statuses are all okay. But you can also do what's called a walk. And TKMIB has this as well. There's a button down near the bottom of the TKMIB window. There's a series of buttons, and one of them is a get, another one is get next, and you don't need to worry about that one. Typically you'll just do a get or a walk. So here we're at the device table entry. I could just say a walk, and that gets me everything for that host. And now you can just scroll up. That's really useful when you want to find out what's available. And you don't want to go read through or browse through the entire MIB tree. Sometimes these MIB files are really big. Cisco in particular, you can monitor anything from about a Cisco device. Their MIBs are huge. So sometimes it's easier to just get to something that you think is going to be pretty close to what you want. Like, we'll go to cooling device table, and we'll just monitor everything from there. And it may take longer to actually go and fetch it, but then when it does, you've got a whole slew of stuff that you can poke through and look at and decide what you want to monitor and what you don't. All right, so let's talk about some of the different data that's in SNMP and how they're different and why they're different, because that can be kind of important. So we've got our server here, which is running net-snmp and happens to be a Dell, and it supports the MIB2 branch, which means it should also support the host MIB. If I can find it, there it is. And we can look at, we mentioned the device, and the processor table, processor entry, and the processor load. So here's our 4 CPUs. Yeah, it's an old system. And you can see they're all somewhat busy. But notice that they're just a scalar value. It's just an integer value. If you look in the description, it points out that what you're looking at is just the average measurement over a certain amount of time. Approximately 1 minute. And this is showing all the 4 individual CPU cores. If you wanted to get an aggregate reading, this is not you'd have to grab all 4 values and then average them together. And most importantly, it's just a point in time. If you're monitoring over 5 minutes, this is just the last minute, what the CPUs look like in the last 60 seconds. That's not great. And it also doesn't tell us anything about how the CPU is being used, right? It just says it's being used. But by what? By the operating system? By the Oracle database on it? What? We don't know. So this is where some of the private enterprises stuff gets more interesting. If we go all the way back up, and we go to private enterprises, UC Davis, and system stats, I believe. Yes. And let's just walk. You see there's a whole bunch of stuff. Well, let's not walk it yet. Let's look at SSCPU user. Here they're pretty specific. They say this object is deprecated in favor of SSCPU raw user, and this is only looking at the last minute. But you'll notice that it shows us the aggregate of all of the CPUs, the user CPU. So that's a little better. You've got at least user, idle, system as separate entities. But let's just walk the whole MIB tree and take a look at what we've got. So here, if we look at the raw values, that's clearly not a percentage. It's not 0 to 100, clearly, right? But we have a lot of them. We've got user, nice, system, idle, wait, kernel, and interrupt. So let's grab user, the raw, I'll just grab idle, the raw idle, and see what that looks like. So here, we're talking about the number of ticks, and they should mention in there that, yeah, here we go, it's a 32-bit counter. So the reason that's important is that if we, here's what the value was just a few seconds ago. If we walk it again, see how the value keeps going up? So what's happening is this is the number of CPU ticks. The aggregate of all these CPU ticks, if we take, I'll show you. Let's walk it, wait 10 seconds, and then walk it again. Okay, that was about 10 seconds. So that should be 2 values separated by about 10 seconds. And let's go into PC. We'll say this minus that. Oops, I missed on the first value. There we go. So that was 705 in the span of 10 seconds. If we divide that by 10, that's 70. So that's our CPU usage, our CPU raw idle. So that's our idle CPU in 10 seconds. That's not a lot of idle when you figure that these values with 4 CPUs go between 0 and 400. So what I'm getting at is that these are counters, and by themselves, this value doesn't tell you anything. It's the delta between the two counters that matters, the delta divided by time. So the way you monitor this sort of a thing, and this will matter when you're going into a tool like Cacti and you're telling it, I have a new data template, and here's the MIBOID for it, and I want you to call it idle CPU, and it's a 32-bit counter. That tells Cacti, I can't just look at the value. I have to look at the value now and save it, and then 5 minutes from now or 1 minute from now or whatever my monitoring interval is, look at again, and then measure the difference between the two, and then divide it by whatever the interval was in seconds. That's the value for, in this case, idle CPU. So that's the difference between just an integer and a counter. And you can find counter 32s. There's also a type that I mentioned in that fiber channel management MIB that's a counter 64, and it's a hex-encoded ugly thing. But Cacti, newer versions of Cacti know how to decode it and deal with it. Most SNMP tools do. And if they don't, it took me like 20 minutes to write a little bit of Perl to parse it out. It was not a big deal. So when you're dealing with the SNMP monitoring tools, keep in mind you may need to know what is the type of the value that you're telling it to monitor, and how often do you want it to monitor it. And the reason that's important, now, if we were just looking at that host MIB, which is unfortunately all I've got for a Windows system, they don't support this concept of CPU counters, but you can go to the host MIB, you can look at what their CPU usage was at a point in time. And you can look at it, I think in the host MIB it's supposed to be the last 60 seconds, but if your polling interval is 5 minutes, your graphs are not going to really truly reflect reality. What they're really looking at is what was the average CPU for the last 60 seconds at these 5-minute intervals. And you see what I mean? That's the difference between measuring the average, all of the CPU ticks between that time span, and dividing it by the time span. You get an average of the CPU usage over that time span, versus just measuring what is the CPU usage right now, or what was the CPU usage for just the last 60 seconds. Right? That's the difference. It's like measuring load average. If you look at load average in the host MIB, load average is an integer. Actually, I guess it's a floating point value. It's a decimal value, but it's a fixed unit. It's not a counter. It's just what I think Cacti calls a gauge. It's just a value which then it will draw on the graph and save in its data file. Versus a counter, and all of the internet or Ethernet traffic stats and error rates, those are all counters. So when you're looking at bits per second, for instance, you're not looking at what are the bits per second for the last 5 seconds. Right now, you're looking at what were the bits per second between the two times that I last checked this value. So that should be enough to at least get you started with SNMP. Start browsing around in your MIBs and pointing it at your devices. I didn't ever show you that, did I? So you probably figure this out on your own, but with TK-MIB, when you want to monitor the values for a specific system, you can put in the host name here. You might be able to put in multiple host names separated by spaces. I haven't tried that. But you can put in a host name or an IP here. You can come into options and say use SNMP version and pick the version you want to use. If you're doing SNMP v3, you can set those specific options here. You put the username and the password and authentication type and things like that in there. If you're doing MIB2, you can set the community name here. And then when you get to one of those leaf nodes in the branch, when you drill down far enough, or when you're ready to just walk the whole MIB tree, if you go, I wouldn't walk all of internet. That'd take a long time, and it would just flood this window panel here with data. But if you drill down to the specific thing that you're interested in and then click on walk, it'll do an SNMP walk against that host for all of the things beneath where you're at in the MIB tree. So that'll get you started. Start poking around in your MIBs, look at your devices. If this is interesting to you guys, let me know. Leave me some comments. If you have any questions, especially, leave me some comments. And if you're interested, I can do a whole nother video just on Scotty and getting it up and running and some of the cool things you could do with it. I'll show you how to use the diagramming tool and how to set up your own monitor jobs and things like that, how to set up the trap sync so that devices can send you traps. Or I can have another separate video on cacti and nagios and how do you set up some of those plugins that I use for monitoring chassis stats of devices, monitoring the power supplies and temperature sensors and fans and things like that. How to turn those into cacti-like graphs in nagios. If those things are of interest, let me know. We can do a how-to video or a series of videos on that as well. Talk to you guys later.